All right, so I'm recording this one. If you have questions, let me know. What I have done here, yes. No, no, no. I already did it. So I have already done that download part. So in this document, the StarNet program that we have, right, is something that has been written by some other scientists, and we're not going to rewrite, right? We don't want to rediscover the wheel. So you should have access to a folder, right? So don't delete anything in there, okay? Inside the PC, there is a place. So this PC, C folder, C drive, and inside that there should be a folder called Siril, and under that Siril, right, you have StarNet V2 CLI Windows. That's the software that we are going to be using today. That's written by somebody else. So watch me again, okay? Go to like a my doc, on the bottom, there should be a folder, right? That's my Explorer folder. Can you guys see that folder? And then on that left side, you should see PC, this PC, right? So that this PC should have then devices and drives, shows the C drive. Under that, click on Siril, and you will see the folders that we're going to be using today. Okay. Raise your hand if you have questions. Okay, please. Our target for today is located inside October 3 folder. Okay. That's my October 3 folder. Our software is located inside StarNet V2 CLI Win. That's the software that we're going to be using. Because I have already installed it for you, all of the computer, thanks to the IT. We don't have to redo it. Otherwise, sometimes it can be pain, for people who have worked on software, the frustrations of something that not working, right? But, we were able to figure it out. So it's already in the system, okay? So this is 2 folder system here. This is script is, ignore that for now. Target October 3. This is just a convention. Okay, that's better. So these biases, darks, flats, lights, these are like the default folders that the Siril script will look by default. If it is not there, it becomes angry, it throws the tantrum, it does not work. So I had to manually create this. So for every new folder that you start working on it, what you can do, like for example, if you wanted to work on new target, you can just copy this, for example, right? And then paste and then rename it, right? Like that, like October, let's say you wanted to work on October 4. Let's say that you wanted to work on October 4. Some new target, right? It could be any other target, this is just an example, right? If you wanted to work on that, then you will replace that fit file with something else that we will have. So, so every time you work on something, you want to create a copy of that October 3rd folder. That's like your master copy, so that you don't have to recreate all that baby folders inside it. Does that make sense? We're going to replace this fit file that is there. That's with the fox picture there. Is that a fox? That's a fox, right? That's basically a head of a fox, I would say, from a software called GIMP, G-I-M-P, okay? That software is open source Photoshop kind of software, right? So that fit file is the one that we're going to be working on. These are already created here. Okay, I'm going to stop here. Do you have questions? Does it make sense? We have 2 folders, right? Inside the Siril folder, we have StarNet software that has been installed. Target October 3 is the folder that we need for processing. The fit file is the one that we're going to be working in the Siril. Okay, are we good? Moving on, okay? Please stop me. All right. So this is the software. Now, later you will be able to follow this, on your own pace, because I'm here, I'm going to just like, I'm just doing it. So the first step is viewing and stretching the image, right? All of those things that I'm talking about, I'm going to demonstrate in a minute, okay? So in the Siril, one of the things that you want to do is, you see that up here, this is WSC file 3 and Malakar, my document, my picture. That on the top, you see, that's like my working directory. Like that's my current working directory, right? But you know that my working directory is going to be, so if you click on the home and then C and then Siril, right? And then target October 3, open. Then it sets the working directory. Did you see that? I need to see the thumbs up once you're done with that, okay? Very good. Set the working directory to October 3. How do you do that? Thank you. Go to click on that home icon, Windows, and then go to Siril, and then October 3, right? And that's my target working directory. Once you hit that enter, on top, below that title, you should see C Siril target October 3. That's our working directory, okay? And this is specific to this classroom, okay? If you work on your PC, that folder can be named whatever, you can name it a dog's name, cat's name, your snake's name, whatever you have, right? Alligator. So everybody, I need to see the thumbs up if we are good, okay? All right, thank you. Raise your hand if you have trouble here, because I don't want anybody to be stuck and left behind, Okay. We good? Just please don't hesitate, okay? Okay. So the civil software is civil software is here.
Oh, okay. It'll see.
So this is the software that we're looking at, right? And how do you set up the home? Click on that, click on that home, and then microfilm sync. Yeah, and then after that, I'll go into video, if you add that, yeah, double click, and then click on upload. Yes, and then click open. Very good. You see that here? That's your working video. Okay. All right. Uh-huh. So, yeah. So you want to basically click off that. If you open that, then your file will be open. You don't want to do that. Oh, you want to open the file. If you want to basically click on the home, first, see. Set the folder. Set the folder. So first set the folder, and then back up to the video. Okay. So on the top, if you see target October, right, 3, then you're good. Like if you ask me once, you may look like silly once, but if you did not, later you'll be working on the homework and you will be in bigger trouble, right? I want everybody to be able to do it because this is a useful skill for all of us, okay? All right, everybody done with that. Now, do you guys remember how to open the image? Click on that open button, right? And then over there, you will see a fit file. So because we have set up the home folder, October 3, when you click on that open, open button on the top left, right? If you click on open button on top left, it directly leads to October 3 and there is a fit file. This is that type is .fit file type. So that's the one that we're going to be working on. Okay, open. Okay, this is the beauty. Look at that. On the left, you should see a dark palette, right? With some like barely visible stars. This is where our last week's skill come back. Okay, this is the image first light. That's what we have. It's barely visible, kind of boring. And then what you can do here is you can go into this. This is like called linear stretching, meaning that your image is like on a linear scale. Basically is not transformed here. So you can do auto stretch to see what's in there. Okay. Click on the bottom here. On the bottom, you should be able to see auto stretch option. Okay. On the bottom, there is auto stretch option. Right. Okay. And then that should give you this. Again, this is just a temporary viewing. This is not the final image. This has not been touched. It's just like a preview of what is coming. Okay. That's the fit file, meaning that that's the image that we got, and that's the information that is available inside that picture. Okay. Everybody good? Okay. If you have trouble, please don't hesitate. Okay. We meet once a week, so I don't want you to be cooling down for next week, right? Until we are like, okay, too late. So that auto stretch basically helps us look. And some of the times, you can do different kind of transformation to see which one works better, right? There are different like algorithms available there, but auto stretch is like automatically, computer is smart enough in this case, or the algorithm in the computer is smart enough to basically do that. Okay. All right. So that's that. Now, if you look in this carefully, on the side here, do you see like there is like a little bit of hoo going on? Hoo going on here. You see that? Like, this one looks like that. And then over here, you see some kind of like a weird noisy pattern. Do you see that? Right. Our eye is pretty good at figuring these out, right? So that like a, right? So red, green, blue palette, you can see that there is some kind of weird thing going on. That can happen because whenever we are taking the pictures, because this is a stacked image, meaning that we stacked, like a 10, 15 minute of data on top, meaning that, if you are taking a picture every 10 seconds, right? Every minute you get 6 of them, right? In 15 minutes, you get 90 of them, okay? So you basically combine them together. So what happens during that time, telescope may move a little bit, right? The atmosphere may produce some kind of, turbulence. There can be many factors that can lead to that noise of some unwanted kind of noise. So that's what you're seeing on the side, okay? So some of the times what you can do is you can like basically bring your cursor here and then basically, crop it out. So you can click and drag. So like, yeah, go the zoomed out version, right? Don't do this, right? Zoomed out version, and you can crop it out so that you kind of like get rid of that. You can see right over here, you can, right? Our eye is much better at looking at those, right? So you can see that you don't want these in your final image, right? So there will be lots of data from there, but it's in favor of the good ones here, okay? You can right click on it and then crop it out. So once you have that, you can right click and then you can crop. Okay. Once you have that selected, right click and crop. So that crop gives you a nice, better, hopefully, right? I mean, there will always be some noise there. And also there are like different ways of doing it, but any questions so far? We selected the ones, the pixel area that we want, we right click and we crop it out, right? So whatever we have is the image that we have, all right? Okay, we good? Now what we want to do after this is we want to check whether the software is good to go. So over there, do you see the hamburger menu over there on the right side? That's called hamburger menu, right? Because it looks like one. That, right? And then click on preferences. It's on the manual too, okay? Click on the preferences, miscellaneous, okay? The hamburger menu, I'm going to try it again. See that? That hamburger menu, preferences. From there, go to miscellaneous. And then there you should be seeing that software location. Software location, click on that folder. Okay, I'm going again, okay? Just to make sure. Look. Hamburger menu, preferences, and then you may get this one, whatever you get, go to miscellaneous, and there's software location there. And then from there, again, we're going to go PC, C, Siril, right? Starnet, and then click on Starnet++. Okay. Select Starnet++ software. And then click open. For today's exercise, this software must be pointed at the right location, otherwise the program does not work. That was my problem with the map. Okay. Go to scroll down, PC. There should be this PC here, and then see. Very good. And then Siril, go down, up, down. Then start it in up. Yeah. And then start plus. Very good. Okay, apply. You good? All right. After you do that, hit the apply button. This basically is pointing, right, to the software location. So whenever you call it for processing, it will call the right processing. Again, this one is written by somebody else. Okay, I did not write it. You can look at the script itself, and there is a credit. Like who wrote it and how, what is going on. So look, on this one, what we have done so far is that we have checked, right? We have made sure that we checked our Starnet++ software is loaded. So this part is done. Okay. I have grayed out the next step here because this one we're gonna deal with it later. But I have told you about the features of the program, right? Where there are biases, dark, flat, light. So these are like the specific features of astrophotography, camera, for example. If you use Canon camera versus Nikon camera versus other ones, there are like the biases, the dead pixels, flats. So we're gonna be basically doing that later. Okay, but this one, in this case, we don't have to worry about that. All right. So you have the picture loaded, right? And then we have auto stretched it already. So you have this feature is looking at it. If you go back to linear, it has not been changed. So it's gonna be like that. So next step, as we have done in the previous case, is the histogram. If you remember, we did a sin h transformation, inverse sin h transformation, as well as we have done the histogram stretching of the picture, right? So we're gonna apply that. So that's the previous homework that we have done. Okay, and again, this is where the art comes in, right? You're gonna do a sin h transformation here, right? And then you can like stretch this a little bit. So I basically, look, I can go back to linear here. Sorry. Let me track back. So I had the auto stretch here just to make sure that I had the right image. Okay, but that's not our true one. So I'm gonna go to linear and then image processing, assign as transformation, and then increase this a little bit so that the feature will be barely visible. Okay. So, again, there is no right answer in this one. Okay. I'm keeping it around 35. Some people keep it at 20, 15, whatever is comfortable for you. This is an experiment you want to try with yourself, okay? Because you want to find out what works, what looks best for you. So once you have that transformation, just apply that, and then that basically kind of like a pre-enhances. It's like a pre-stretching, right? It does that, and then you want to do the histogram transformation. Do you guys recall this? Histogram plan. This is the homework, okay, from last week. So this is where we were last year, right? It took us a long time, but right now we are like, boom, right there. Okay. So this is histogram transformation. If you remember, we can start by auto stretching it. Right? If you do the auto stretching, the histogram transformation takes that information. Right? Auto stretching button is here. Okay. This like a mechanical button over here. If you click on that, it saves you a lot of work because theoretically you should be manually moving that, right? Midtone, shadow, highlight, all that fun stuff. But hey, there is a feature that is available. It's data based, so it basically gives you that feature. Okay, we good? Okay, and then I mean, if you are into it, you can like zoom into this histogram, right? And then you're gonna play with it. Yeah, be my guest. Like, look, I mean, again, this is where the art comes in. Okay, so there is no perfect answer here. However, you can tell a good picture from the bad picture, right? Does that make sense? Like, there is no perfect answer, but there is, right, the measurement of the quality. You wanna like you can tell good effort versus not so good effort. Does that make sense? Right? So do as you please. Okay. You can see that the clip percentage is not there, which means that we did not clip any data, so we are good, right? Like, if you go into this upper extreme here, like if I zoom out, and then if you do this, if I slide that white down, you can see it changes that contrast of the image. you know I'm usually not big fan of moving that guy, because stars are important feature for me, so I'm going to keep it like that. Okay. So right now, I have like a stretch it a little bit, mid-tone, shadows, and highlight. You can see there are numbers in there. An interesting feature of this program is that once you stretch that, it puts that stretch prefix on the file. Okay, it puts that name in there so that when you save it, it will have that stretch feature in there. So hit apply. Once you hit that apply, now it is applied there. Okay. And then close it. So that's where we are at. So this is the image that we are looking at right now. It has all the features. It has stars, it has the gas, right? Everything that you need in that image is there. This is transformed image here right now. Okay. Now, after the histogram transformation that we have done, okay, so we have done the histogram transformation. Now we're going to extract the background from the image, because image has background, and then there is like the actors, right? The gas, the star, all that. So we're going to extract the background, extraction. And that can be done again by going back here, image processing, okay, and all the way down there somewhere. See that? There is a feature called background extraction. This is the main part of our class today. Exercise. Background extraction. We're gonna do that. All right. Couple of interesting features in here. So you can individually do the red, green, blue, all of that, but I don't usually just the smoothing. The sample per line basically means how many, if I hit this generate, you can see it generated the squares, right? So sample size of 20 means that it has generated 20 row, like 20 columns or 20 squares every row. Okay. You don't want bright stars inside that square. Does that make sense? Because if you have the bright star inside the square, that means that is taking that as the background, and it messes up your meaning. So you don't want that. Okay. So what do? We can left click, right? For example, over here, do you see that? This guy? Let's pick some of the bad examples. Over here, you see that this one has a star in there. You want to right click on that. Right over here, you see that it has star in here. You want to remove that. You can, this one definitely is a candidate for removal, right? So you want to right click on the pixels that has bright star in it. Okay, so if you right click it, it basically takes away. Also, you don't want, remember your Pacman Nebula has a feature here, right? So that gas you don't want as the background, because otherwise it will be washed out. So you want to remove that too. If you want to add a point, for example, right? Let's say that you removed a point by accident, right? Like you removed a couple of points by accident, and then you wanted to add that, you can left click. If you left click on a place, then it will add the point. Left click adds, right click removes. Okay, do as you please. So I'm gonna like remove. pretty sensitive about this one. So I'm gonna like look manually row by row and then remove the pixels that have any bright star because it's gonna mess up my calculation otherwise. Right? There we go. So right click removes, left click will add, okay? Okay. So I'm pretty happy with what I have. Again, it's on you, right? Whatever works the best for you. Don't just go manual, I mean, crazy, right? you know. All right. After you're done with that, or after you're happy with all the points that we have, then hit this blue button that says compute background. It will take a minute, okay? So once you hit the compute background, it basically will calculate it on the background and you can hit apply there. Okay, now it has generated the background for us. Okay, if you look at the console, it shows you it took 274 milliseconds, which is not really too much time, but you got the idea, right? So it has computed the background. So this is the major part of our work today. Okay, background extracts. Yeah, it's in the manual too. So I have clicked, right? I have like a chosen the point. The grid tolerance can be changed. You can, for the homework, you can play with that to see, how that affects. But once you have that, you have this red squares everywhere and you extract the ones that are not good. And then you compute the background. Once you're happy, once you hit the compute background button, it will basically compute the background for you. What is that useful for? Because that background is based upon where they're going to decide whether there is a star or not. Because our goal right now is to basically find out those bright pixels, those bright stars, and then once you have the bright stars located, you can extract them out. Okay, you will see. So after you are done computing the background, right, this is sometimes, there may be a green tint a little bit, but that can be done later. So you can do now color calibration. Okay, you want to do photometric color calibration. Okay, I'm also showing you this because I don't want you to be overwhelmed by all the process. Okay, you see that color calibration is what we are doing here. Okay, color calibration, photometric color calibration. Right now, I was careful in giving it the name, and the software when I saved this, it saved the coordinate called right extension and declination. Declination is like how much declination is there. Right extension is like going, left to right and right to left, right. So it has the coordinate system already, in there. If it is not, you can look it up. There is like this over here, right? So you can basically look up NGC. This is just an optional step for now. Okay, NGC 281. So if you do that, you see that, it has like those star catalog already, in a server that's saved. So sometimes if you took a picture blindly, right, like a smartphone as an example, and then you had no idea the coordinates for this, RA and G, these. So in that case, you can calculate that, and it can populate this coordinate for you. Yes. Oh, I basically was looking up NGC 281, but in this case, it's optional because I already have the RA and declination information already loaded here, So I can either do that or it is for this case, it's provided. I'm just showing you that it can be done, so you can look it up, right? So if you hit NGC 281, hit the find button, it basically gives you that, right? So if you have that, we're good. For our telescope here, the focal length in millimeter is 250, and then the pixel size is 2.9 micrometer. So every pixel is 2.9 micrometer. So that's already there. Sometimes if you have a camera, that information may not be available, but then you can Google it, like what is the pixel size for my Canon camera? You can look it up and you can insert it in there, okay? That basically tells you the resolution of the picture because, a computer needs to know the resolution to basically, compute the background and then overlay the star for color calibration. So once you do that, there are other options. I would not worry about that right now. Okay, hit enter. Okay, you can click on that OK button after this. So on the right side, you will see there is some, on the console, you can see some dialog coming up, and then photometric color calibration succeeded. You should see that prompt. If that fails, then we have to redo it. Behind all of this, what is happening is there is like a command line, interface that's happening behind this. This makes our life a lot easier by clicking and just going around, Okay. Any questions? Okay, I can close it. Just to be on safe side, I usually remove the thing called green noise. On the image processing, there is a button called remove green noise. You can click on that and then just hit apply. So the image kind of looks more reddish, right? You can do this. Look, this is before, this is after. Can you see the difference? The monitor may not be good enough, but you can see before and after, right? So this is before, kind of like a greenish tint. And if you do the green removal, noise removal, then that basically shows it's kind of like a reddish hue there. Everybody okay with this, guys? I know it's a lot of step, but that's why there is a manual on the side. Don't be overwhelmed with all this. Okay, it's like everything is written in here. I have put a lot of effort to make sure that whatever we do is indicated in here. So we are right now over here. Photometric color calibration is done. So we have done that. And then up, in the previous description, I have also written like a remove the green noise. So it's already in there. Okay. So I have removed the green noise. I have done the photographic image calibration, right? So I think our image is going to be good for as prime time now. So next step is star removal with the software that we install. The Starless software that I indicated in the beginning, that's where we are going to go. Okay. So in this case, image processing, star processing, StarNet star removal. Okay, click that button. Click on pre-stretch image, linear image, right? Because pre-stretching is good for you. Saw that why pre-stretching was important, right? And generate a star mask, and then hit execute. Okay. Once you do that, magic will happen. There is actually a number crunching that is happening in the background. Okay. So you will see that it took 8 seconds to calculate all the background. And then after it is done, a red button, red, sign will be there. That means we are done. See that? Stars are gone. So it basically removed all the stars from that calculations, right? So that's our gas where the stars are being born, okay? The nice thing about this gas is that now you can work separately with this gas so that you have, you can now don't aggressively edit the histogram after this so that it looks like a cartoon, kind of thing, but play with it, Like I can already see like her image, for example, has like a red hue that I want to have, right? You know, there is like a red sign kind of thing that I'm seeing. That's pretty good, okay? Better than mine, you know. Uh, oh, this is from the last week. That's it, the histogram. Okay, so in this case, you saw that, right? This is starless, right? Gas. I do agree that this is noisy, right? It now I realize it's only 10 minutes. People go crazy on this. People calibrate, or I mean, people basically collect 2 hours of data. And once you have 2 hours of data, those speckle noise that you see, that actually is going to be washed out. Really nice, you know. That's 10 minutes. It's actually like a small cookie in the astrophotography, you know. 1.5 hour, 2 hour of data on different days, you know. So people do that and then they get a lot better pictures. Okay. But here is the thing, right? So we have this. So we are here right now. Look, we have done the star removal, right? So that part is done. And some of the times in professional, like people who work at NASA or JWST, Hubble, they basically, take this kind of image and then they process it in Photoshop because they want to apply the already available software that is like useful for stretching the histogram in a better way. You can do that later, but for today, we're going to just use Siril's histogram feature. Okay. Because I mean, that's what we know right now, right? So over here, you can again, basically do histogram transformation here, right? There we go. You have to play with it, and then some of you will have better image than me. I will admit to that. I have no problem admitting to that. Right? You wanna have the image. So basically play with it. So this is like a starless, stretched, stacked, image that I have. I'm not fully happy with it because I was doing the demonstration and but you guys might be able to produce better histogram stretching than I did. Okay. All right. So show me if you have better ones. Like I want to see red hue. In the beginning, do you remember I showed you that the Hubble, image was like with a lot of red, right? Oh, okay, good. You guys are good. Look at that. Uh, right. So did you like modify the red ones? Oh, turning off. Man. I really want to see the better ones. Yeah, try playing with it. And then once you're happy with it, you can apply, right? You can apply the histogram stretching multiple times, as you know. Just make sure that you're happy with what you get. Again, we are working with the noisy data for now, but that's fine because later we'll have better quality data. Who knows, some of you will be collecting better data later, but I mean, I'm not totally happy, but this is where I'm at right now. Okay. So I would do that and then close the histogram stretching part. Okay. This is my starless histogram stretched image with the Pacman feature there. Right. I'm losing some of the red hues in here. Right. I'm really not happy with this. I'm sorry, but ah, okay. Can I cut off blue a little bit more? You can also individually work on individual channels. Like, I was able to see that this is the blue channel that I was playing with. Now added red and green. Green, red, blue. Okay, better than previous, I think. So I'm just like trying to remove blue, but I cannot remove too much. Then it will look like a purplish star.
Professor, am I still going so worried about noise?
Right now, no, because what's happening is that this one, doesn't have enough signal. It's my fault, right? So I'm not going to penalize you. Don't make it too much noisy, but you got the idea. I mean, better than mine. Can you like pop out red a little bit more? Okay, I like yours, okay, because you have that red coming out. You know, we know that there is like a yeah. So yeah, look at this one also is good, right? So you can see like the red things are coming out. It's really nice, That's where the hydrogen is, right? So again, it's me. I'm the problem, you, right? Is that the song? Okay, so we have done that. Okay, star removal with StarNet. Now, what we want to do is we want to save it. Okay, so hit that button, save. Okay, over here on the top right, there is a button called save, right? And then on the folder, you can confirm that. If you look into this folder here, you can see there is a star mask and there is a starless stack. So once you hit the save button, you should be able to see star mask and then starless stack. Those two. This is our original. This is what we have generated. Okay, we have generated star mask, which is bunch of star, and then starless, which is the gas. Okay, look into the folder to make sure that you have it. Okay, now the fun part. Stop me, please. Okay. Now, last step. Last step is recombining the stars. So we have separated the star with the starless, right? Now we want to combine them. Okay. All right. So over here, image processing, right? Star processing, and then star recomposition. Okay, I'm going to show again. Look, image processing, star processing, star recomposition, as the name indicates. Okay. Now, there is a background star stress parameters and star stress parameter. Background would be our starless stacked, right? And then foreground or the star stress is going to be star mask open. Okay, there we go. So now we have two layers. One is the starless, right? Yes. Another is the star shrouded features. You can still play with these guys. Look, this is not done yet, right? So you can like literally play with this until you are happy. You can control the intensity. There are like a symmetry point. Usually I leave it alone. So you can like see if you increase the star point, see that star doesn't look good, right? You can tell, right? So you wanna you wanna have that good balance between what this is where the class gets that art designation, right? Because this is what you feel about your image, Okay, so you wanna put enough like you wanna put enough stars in there so that it looks cool, but you don't wanna overdo that. You don't wanna do that. Make sense? Right? If you feel like it, just ask your neighboring friend, and they, if you get the sense that the feeling answer is you, then that's not right. Okay. All right. Once I'm happy with what I get here, I'm gonna hit apply button, apply. Okay. And then close. Okay. On now over here, you see that unsaved star composition result. That's what my final answer is right now, right? Unsaved star composition result. You can click on that down arrow button. That basically says save the current So that's, I'm gonna click on the original and then put my name on it. Do you remember our convention was that underscore my name, right? Underscore 2024, 2024, zero, no, that's not, no, the 1020, what is it? 1003. See that? So I have basically added my name at the end, right? That basically shows what I have done with it, right? Once you are done with that, you can hit, right, the save button, save button, save it as 32-bit floating point, okay? Save. Uh-huh. So you click on one of the file name and oh, okay. So, yeah. So, Starless. Okay, so this one, no, no, and then you play with that. Okay, this one is nice because if one like it, see that red pulling up, that's cool. Then when you hit apply, close, and then you hit that down button. Oh. And then you click on the original name, and then over there add your like name before the dot hit. Look at that. This is cool. I like when you guys have that red because I know that that feature is there. Okay, you good, right? Let me know, okay?
So,
Okay. Easy, right? Once you have figured it out, so, I'm going to start with
oh.
um, whenever you search the Instagram, you also change the one, right?
I'm sorry, there's a big. Do I have to get underscore every day or just?
It feels like you have one to do one like that. You want to do something. I mean, this is not first exercise, so nothing is bad. Okay, over here, and then hit on that, and say hold. Okay, you good? Are you good? That's good. Yeah, and then apply, and then you know, and then close, and then there is a button that you can close. And then save it as with your name, okay? Pretty cool. All right. Yes. Oh, there is like a down button. Oh, yeah. That looks cool. Yeah. Yeah. Let's click on that. And then before dot fit, add your name and date. How you can use. Okay, well, look at that. What is this? That's a Photoshop? Oh, yeah, you opened it with something else now. It's a Photoshop. Right. Okay, hold on. So this is the Starless, right? Very good. Can you click on this? Okay, this is the glass, right? Can you hit save button? Okay, can you go to your folder and let's see how it's going? Go to that. Starless, right? Very good. So go to this processing. Start processing. Yeah. So now, Starless. Okay. Yep. Click on this. Now, without, I think your star mask was too aggressive. Does that make sense? So you want to like redo and then so the process is this, right? So you probably want to change that, see if it can be the scale. So which star mask was here. So anyway, hit apply. Good. And then it's not saved, right? So you can hit that button. You can do it. So that, okay. Everything, but this is right. Hey, all right, guys. There was a question somewhere.
Yeah, yeah.
Okay. Yes.
We're all having trouble putting it in.
It's because you put that. Oh, yeah, just like a put 0, like no tax as well.
Okay.
That's a special tax. Yeah. 1003. Yeah. Yep. You can do that. That's good. Save.
Oh, okay.
Yeah.
Well,
Class.
okay, say, right?
All right. That's good.
Thank you.
You good?
Yeah.
All right. You guys are good, right? Three of you? All right. Okay. Anybody else with questions, please let me know. So this is the basic process, guys. Obviously we're gonna move more forward from this in the coming future, but this is the basic process. If I give you any bit file now, you should be able to, the question could be something like, give me the starless gas mask, right? Give me the star mask, so those are two features, and give me the command, right? Your assignment will have three files that you can basically take the pictures of, save, and then something, so that's right, that's how we do it. We're gonna do that again and again, okay, for many of them. So this gives you a manual control on the night sky pictures. And it's not hard. If you have to like a scratch code it, from the 0, then yes, but our science has advanced so much that now the question is, we can make it better. That's practice. That's practice, okay? That's a lot of practice. All right. Questions? This one is the final. You can save this if you are happy with it, obviously, right? If you're happy with it, you can save it on your social media. Look, it's like look at this Pacman Nebula I processed today. I mean, you will be more proud if you went out and then took the picture yourself for countless hours and then did that. But this is the starting point, right? So you could save. Look, now if you wanted to share this, right? What you can do is you can, save as. See that's supported. I usually for social media I save it as either PNG or JPG file. Okay. JPG is kind of like it loses a lot of information, and sometimes this is like a bit. It's like not lossless information, right? So it loses that information every time you save it. So JPG is not my favorite. PNG is my favorite. I'm going to basically save it as PNG, for example. Look, I saved it as PNG. Did you see what I did? I clicked this button, and then on the supported image file, I went to PNG, and then I basically saved it, right? And if you check your folder, okay, this is the PNG file that I generated. You can open with photos, and that's the picture that's ready for prime time. I'll warn you one thing, because of the processing of the software, the image has been flipped left to right. Okay, in the future, you may learn about how to flip it back. But for now, this is what we do. Okay. Do you remember I showed you the Hubble picture that basically had the picture the other way around? But that's the flipping because of the image processing right now. See. Okay. Well, this is your competitor, guys. Look. Don't feel bad about it, right? But this is your base. That's NASA picture, like $1 million. This is our, right? I mean, not bad. Someday this will grow, it will grow the leg and then run around and then it will make a crop. But for now, it's our base, got it. Okay? So feel free to post it. But again, you need to flip it left to right because, the orientation is kind of like this. You got the idea, right? See that? Can you see the features here? This is there. This feature over here. There is this cloud there, And now for reference, this was, this was like from the computer that barely is visible there. So this is my original that I had. This is my processed. Again, this is flipped left to right, but you can fix that later. See that? This one was what I had previously. This one is now your processed image. 1, 2, 1, 2. Which one is better? Right? You can see the features. Right? So we definitely have cropped it out a little bit, but obviously now you have more data there. I mean, not more data, more visibility in the chart. Okay. Any questions? No, everything is clear as mud. Again, let me review briefly. We are doing the histogram stretch, right? We are learning how to do the star mass, starless mass, combine them, and we have them. Okay, that's the process. Obviously, because we did it for the first time, it looks like there is like this and this and this, click here, click there. Obviously, a little bit overwhelming for the first time. But later it's like a click, 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 will be done. It's going to be done fast. Okay. Some of us are computer scientists here. You can even write the scripts. Like you can literally write command line scripts to tell, okay, what you want to do. You can literally tell the computer to do this without manually doing. But the important feature of astrophotography is the human touch. Because whenever you are giving the algorithm to computer is blindly going to do something that you may not have control over. But when you have like a stretching it manually, then that's like a personal thing that you do to it. Okay. All right. So are you guys happy? Okay. Let's make sure that you have all the things that you need for this, right?